All right, this one says 3 vectors are placed to an object as indicated in the drawing. Yeah, in the drawing, which is this drawing here. Now they say force 1 has a magnitude of 21 newtons. So let's go put it. So this one is 21 newtons. And then the next one, F2, has a magnitude of 15 newtons. F2, so this one, it's 15 newtons. And then the direction of the forces are as indicated in the drawing. What must be the magnitude and direction specified by the angle theta in the drawing of the third force F3, such that the resultant vector of the 3 forces, this is funny, is 0 newton. Okay, fine. Okay, all right, so it makes sense. Yeah, so what they are telling me, this one is the equilibrium. This one, they're telling me it's the equilibrium. So that one, it's an equilibriant. Equilibri. How do you run that brain? Equilibrium. Yay! Yeah, something's wrong there. There we go. Equilibrium. I think it's right here. Because 3 forces. Oh, can you see now? Can you see now? You can see can you see? Or maybe I'm not sharing. Okay, yeah, I can see. No, it was not sharing. I'm sorry. There. Is it the one now? You can see now. You can see. All right. So I'm saying this one is the equilibrium. So what's happening? We are going to find the resultant of F1 and F2. You got it? Which is going to be somewhere here. Now, to cancel the red, we draw the F3 in that direction. We're good, ne? Yeah, there is a way how we can do it. First, we can find the equilibrium of the two. The magnitude of it will be the magnitude of this one. All right, so yeah, all right, so now this is the equilibrium. So the forces we're dealing with it's these two. 1, 2. I know this one is an equilibrium. Let me use a different color for that one. It's the one that cancels the equilibrium. So this one, though they call it force 3, is an equilibrium. It is the opposite of the equilibrium. So let's break them into their components. So the first one will be, I'm gonna go for this one. I'm gonna make it black. It's pointing up, and this one will go in that direction. It's pointing to the left. All right, since I have 30 here, I can do this. This can be 60. Can you see that? Or I can do this alternate angle. If this is 30 here, I can put 30 there. Can you see that? It doesn't matter which one. The answer will be the same. Okay, I'm gonna put the 60. Is that fine? Because it just looked good. So I'll put 60 there for me. And then this horizontal one, I'm gonna call it 21 times, is gonna be cos of 60. The vertical one is gonna be 21 times sine 60, because it's opposite to that one. Then we go to the one on the right. It's the only one there is. It's the only one there is. So let me just make it blue, my blue, and just draw it there. Then we have that one. So we need the resultant of these two. Alright, so now what we need is to move over to the other side. And now I'm going to say the sum of the forces along the x equals to, on the x it's 15 minus 21 cos 16. So it's gonna be 15 minus 21 cos of 60. Alright, and then the other one, the sum of the forces along the y is gonna be, it's only one pointing up, 21 sine 60. So it's gonna be 21 sine of 60 degrees. So let's give the answer for that and the answer for that one there. So I've got 15 minus 21 cos 60. I get 4,5. If you're rounding to 2, I can put a 0, which doesn't matter. The other one is 21 sine 60, which is going to be 18, am I right? Comma 19. These are newtons. This is also newtons. Then I want the resultant. Yes. I'm gonna say resultant. I haven't drawn the sketch. Resultant, it's gonna be 18,19 all squared. I'm just working out the magnitude, plus the 4,5, no need to put a 0, squared. Then I need to give that a square root there. And then the resultant number, the magnitude, 18,19 squared plus 4,5 squared. Alright, so we get 18,74 Newton. This is also the magnitude of the equilibrium of this one, F3. It is. So I'm going to write this is the same as F3, the magnitude. But the direction are going to be different. So let's put the direction. So this one, it's horizontal. It's positive, meaning it's pointing to the right. This is positive, meaning it's pointing up for me. So I'm going to start with the horizontal, which is going to the left, which is 4,5, 0 Newton. And then I've got this one going up, which is 18,19 Newton. And then the resultant, I'm going to go with it in red, which is that, meaning the resultant was going to be here. It was going to be there. So I'm gonna just slash it and say this is the resultant, which is 18,74 Newton. And then the one at the bottom, this one, F3, it's also 18,74 Newton. All right, now let's find the angle. The angle will be here, the theta. All right, so this is the R, the hypotenuse, or the resultant, 18,74 Newton. Now let's get the theta. So theta is gonna be arctangent of opposite, which is 18,19. You're gonna divide that by 4.50. It will give you an angle. Remember, if you were to draw the Cartesian plane from here, it will be like this. That is above the positive x-axis, meaning from east towards the north, meaning north of east. All right, so let's put it in a calculator. So we got shift tangent, open bracket, 18,19 divided by 4.5, and then I'm getting 76,1 degrees. I'm gonna say north of east. It's north of east. So let's go back there. So which means here, that angle, it's gonna be 76,1 degrees. Now in mathematics, you did vertically opposite angles, correct? This and that. So that and that are equal. Do you see that? Vertically opposite angles. So which means this theta, that one. Oh, we also use theta there. I could have used a different symbol. So it's 76,1 degrees, but it's coming from west to south, meaning south of west. So the answer they were looking for, it's this one. Let's write it in pink. So I'm gonna say F3 equals to 18,74 Newton at an angle, okay, let me just say 76,1 degrees, there it is, south of west, south of west. There we go. That's how we're gonna get zero resultant if we have an equilibriant force. It's a force that keeps the other one at equilibrium, at zero. All right.